Hello dear students. Today we are here to discuss the 7th unit of grade 10, that is quantification of elements and compounds. So what is this quantification? In Sinhala we call it as ප්‍රමාණාත්මකව ඉදිරිපත් කරන. So we need to present the quantity of certain substances in our day-to-day life. We'll take examples from large objects to smaller objects. When we take a car, the most suitable unit to present its mass is kilogram. Then if we take a loaf of bread, gram is the most suitable unit to present its mass. Then when we consider something like a tablespoon of sugar, then milligram becomes the suitable unit to present the mass of it. Then if we take a tablet of medicine, again we present their masses by using milligrams. Then now I gradually move from large objects to smaller objects. So if we move on to the smallest substance or an atom, which is the basic unit of matter, then what should be the most suitable unit to measure the masses of atoms? That is what we are going to discuss in this lesson. The suitable units to measure the masses of atoms to present the elements and compounds quantitatively. Now, when we take the smallest unit of measuring mass, that is the attogram, what we symbolize by simple Ag. So, 1 attogram is equal to 10 to the power minus 18 grams. You can see it is a very small value. If you write it, you will have to put 18 zeros after the decimal point in front of 1. So it is a very small value. Then here I have written the mass of a hydrogen atom. Hydrogen is the lightest atom. So the mass of a hydrogen atom is 1.674 into 10 to the power minus 24 grams. Then if I present the mass of a hydrogen atom by using the smallest unit of measuring mass, it is equal to 1.674 into 10 to the power minus 6 attograms. If we write the value exactly, it is equal to this much. So it is clear that even the smallest unit of measuring mass is too big to present the mass of an atom. Therefore came the requirement of presenting the mass of smaller substances or atoms relative to a standard unit. That is what we call as the atomic mass unit. So there it is something like now when we take the balance, there you use the weights like you need to measure 1 kilogram of sugar. Then you have only 250 weights. There to one side you will add 4 250 weights, and until it is balanced you have to add sugar onto the other side. So there, relative to that 250 gram weight, you are presenting the mass of sugar. So there you can say 4 times of 250 gram weights of sugar here. So 4 times is something presenting the mass of sugar relative to a standard unit. Likewise, we need a standard unit to present the masses of atoms relative to that particular standard unit. That is what we call as the relative atomic mass. For that, the unit needed is atomic mass unit. Several atomic mass units were used since the development of science and technology, but nowadays we are using the atomic mass unit as the 1/12 of the mass of C612 isotope atom. So you know about isotopes. So there are several isotopes of carbon. Here we are using the carbon 12 isotope. That means you know 12 is the mass number of that particular carbon atom. So if I repeat, atomic mass unit or AMU used today is the mass of carbon 612 isotope divided by 12. So the mass of a carbon atom is 1.99 into 10 to the power minus 23 grams. Once we divide it by 12, we get the value of the atomic mass unit. It is 1.67 into 10 to the power minus 24. The relative atomic mass is how many times the mass of a given element weighs when compared to the atomic mass unit. That is what we call as the relative atomic mass. Here I have mentioned the mass of C612 isotope atom, and you are given the mass of an oxygen atom. So we need to find the relative atomic mass of oxygen. We symbolize relative atomic mass as AR. So it is equal to the mass of an atom of the element. We need to find the relative atomic mass divided by 1/12 of the mass of C612 isotope atom. Right. So in our example, I will write the mass of oxygen atom here, 2.66 into 10 to the power minus 23 grams divided by 1/12 of the mass of C612 isotope atom, that is 1.67 into 10 to the power minus 24 grams. So by looking at this equation, it is clear that relative atomic mass does not have any units. Relative atomic mass does not have any units. When we simplify the equation, here you can get 2.66 into 10 to the power minus 23 divided by 1 over 12 into 1.67 into 10 to the power minus 24, and we can write it as 2.66 into 10. That means 10 to the power minus 24 goes to the top, it becomes plus 24, and here there is minus 23. Therefore, you can take it as 10 to the power 1. Then here this 12, you can multiply 2.66 by 12 and divide the whole thing by 1.67. After that, you have to do a mathematical calculation. So 26.6 multiplied by 12 divided by 1.67, that is equal to 191.138. So this is the relative atomic mass of oxygen. So here we have presented the mass of an oxygen atom relative to the atomic mass unit.